Hello, welcome to Just Mathematics. I remain your host, Milton Ebiwari John. In our last video, we looked at simplifying indicial expressions. The examples were quite simple. Today, we'll still look at some other examples in this video, which are also quite simple. And then in our next video, we'll look at more complicated questions. And with these basic foundations, you'll be able to solve any problem that involve indicial expressions. Okay, so let's see these first examples. Solution. The first example here says we're expected to write these expressions without brackets in its simplest form. So it's very easy. The first one says we have minus 3a squared raised to the power of 4. Okay, we apply this law that says that AB raised to power m, remember this law that says is equal to a raised to the power of m times b raised to the power of m. Right, everything raised to the power of this is same thing as each of them raised to the power of this multiplying each other. So we apply that law here. When we apply that, it means minus 3 is like a, so we say minus 3 is raised to the power of 4 times a squared also raised to the power of 4. So this term here raised to the power of 4, and also this term here raised to the power of 4, just as we have here in this case. So we're applying those laws we've discussed in our previous video. Now the next thing is minus 3 raised to the power of 4 is 81. Now when a negative number, take note, when a negative number is raised to an even power, when a negative number is raised to an even power, the result is positive. Okay, I'll take that statement again. When a negative number is raised to an even power, even, this number 4 is even, the result will be positive. Okay, for instance, you have minus 3 times minus 3 times minus 3 times minus 3 for minus 3 raised to the power 4. This gives you minus times minus times minus times minus is plus, it's positive. Minus times minus plus times minus minus times minus plus. Okay, so that gives us positive 81. So take note that whenever a negative number is raised to an even number, then the result will be positive. If it's an odd number, then the result will be negative. We'll see that in our next example. Okay, then here is times a raised to the power of 2 times 4. We're applying the law that says am bracket n is equals to am times n. So this is the law we are applying here. Okay, so we are good. So this gives me 81 a 2 times 4 is 8. So that's the simple answer to this question. So let's see this next question. The next question says, this B, it says minus 2a raised to the power of 2 over b or raised to the power of 3. So applying this same law, we can break the elements into minus 2 raised to the power of 3 times a squared raised to the power of 3 all over, here will be b raised to the power of 3. So the 3 affects every element in the bracket. It's true for multiplication and also for division, as I showed you in the other law that says a over b raised to the power m is equals to a m over b m. So I showed you this law before while we were discussing laws of indices. So this and this is what we have used here. Okay, so the next thing is to simplify. Minus 2 raised to the power 3 is minus 8. You see now, a negative number raised to the power of to an odd power gives us a negative number. I'll take that again. A negative number raised to an odd power gives us a negative number. A negative number raised to an even power gives us a positive answer. So take note of these results. And then this gives us times a 2 times 3. Should be familiar with solving problems like that now using this law. Okay, b 3. So our final answer here will become what do we have? Minus 8 a raised to the power of 6, 2 times 3 is 6, all over b raised to the power of 3. So we've been able to write these expressions by removing the brackets. Okay, so that will be all in this video. Please don't forget to like, to share, and to comment on this video. And as well, follow this page. Alright, see you in our next video as we solve tougher problems that involve indicial expressions. Thanks for watching. Bye.